In this video, we're going to talk about the library of functions and how to use it. The functions that we're going to talk about are going to be the constant function, the identity function, squaring function, the cubic function, the square root function, and the cube root function, and the reciprocal function, and possibly the squared reciprocal function, and the absolute value function. We won't reach the exponential function or the logarithmic function right now in this lesson, nor will we talk about any of the trig functions or inverse trig functions right now. We'll get to those in later lessons. So let's go ahead and talk about these basic function types. We're just going to look at the shape here to match this. And this is the square function. Number 2 is a horizontal line. That's a constant function. Number 3, you're going to see is the shape of a square root function. 4 is the shape of the absolute value function. 5 is a linear function, which they're calling the identity function here, but we're going to call it a linear function. And then 6 is the shape of a cubic function, a cube function here, C. The reason the names are a little different here is because this chart is out of an open educational resource textbook. So the names there are slightly different than the book that this worksheet goes with. Now we're going to try and make some XY ordered pairs here for the characteristic points. 5 characteristic points of the identity function right here, where you can see some of the characteristic points there. We have 0, 0. We have 1, 1. We have -1, -1. If we wanted some additional points, we have -2, -2. We have 2, 2. Let's at least get 3 points here. 0, 0, 1, 1, 2, 2, -1, -1, -2, -2. And we should have the line through the origin that has a slope of 1, right? Like that. Let's try y equals x squared. X, y. Characteristic points for the squaring function. We see them right here. 0, 0, 1, 1, 2, 4, -1, 1, and -2, 4. That's 0, 0, 1, 1, -1, 1, 2, 4, and -2, 4. My squaring function is going to look parabolic. Hopefully it looks symmetric to the y-axis there, since it's an even function, and it should look something like that. Now let's try y equals x cubed. Its characteristic points are going to be 0, 0, 1, 1, 2, 8, -1, -1, and -2, -8. See if we can get all of those here. I'm not going to be able to get all the way up to 8 or -8, so I'm going to have to deal with just the ones here. 0, 0, 1, 1, -1, -1. It's right there. And this is going to have a shape where 2, 5, 6, 7, 8. It's up here somewhere. And -2, -5, -6, -7, -8 is down here somewhere. So it's going to quickly grow like so. and it has that kind of an S shape to it. It's gonna, as you see it, it kind of levels out for a second at 0. So I should have made this a little bit more pronounced, that it's kind of flat right there, and then turns and goes back up. You'll get better at drawing that as time goes on. X, Y, and be careful here with the square root of X, because it starts at 0, 0, and then the square root of 1 is 1, and the square root of 4 is 2, and the square root of 9 is 3. And I don't have 9 on here, so I'm going to stop there. So we've got 0, 0, 1, 1, 4, 2. And the shape looks kind of like that. It gets shallower and shallower. It flattens out as I go along. Now let's try y equals the absolute value of x. It's got the point 0, 0, the point 1, 1, the point 2, 2, the point negative 1, 1, and the point negative 2, 2. So there's 0, 0. There's 1, 1. There's 2, 2. Negative 1, 1. Negative 2, 2. So there's that line with a slope of negative 1 going off to the left, and that line with a slope of positive 1 going off to the right, and it makes that sharp V. Now let's try this constant function y equals negative 2. So we can get some points here. If we want negative 2, negative 2, negative 1, negative 2, 0, negative 2, 1, negative 2, 2, negative 2. They all have a y value of negative 2. So just a whole bunch of points along this horizontal line right here. Let's see how I do it drawing a horizontal line. Not too bad. It's actually one of the harder ones for me to draw on the computer. All right, so that's all of them that we have for practice in this section. Go ahead and make sure you memorize all of your family, your library of functions here. Sometimes the teacher will call these parent graphs because we're going to transform them, and we say that when we transform the parent, we make a child that looks like the parent, has a lot of the same characteristics, but it's different. So we did not do a cube root, and we did not do a reciprocal. We did not do a squared reciprocal, but go ahead and learn those as well. See you for the next video.